So I'm Stephanie Kidd with Holler. Of course, I'm with KVIC. I'm a math consultant here. And today we're going to talk about effective math teaching practices for all students.
I'm Brenda Combs, and I'm the lead here for the monitoring and results.
So let's get started with the standards for math practices. I can talk about these all day long. We could be here all day, I promise. And with the standards for math practice, we need to make sure our students who struggle with mathematics definitely have each piece of this. And I know you're sitting there looking at the first one, making sense of a problem and persevere in solving them. And you're thinking, what in the world can I do to get my students to actually make sense of a problem? Many times it's just talking through them, using something that they understand. A good example is if I'm doing a division problem. If I want them to make sense of the problem, we may actually use counters to divide the problem. So if it's 21 divided into 3 groups, I would have 3 plates there. I would have 21 counters, and the student would divide them into 3 groups. If it is a problem such as it's got a variable in it, one of the things that I may do with that is, if let's say it's 2x plus 2 is equal to 8, right? So it's 2x plus 2 is equal to 8. I'm going to have them to have 8 counters. They're going to, I'm going to say, now we added 2 to this, so now we're going to have to what? Remove 2. So now we're at 6. Now I've got to fair share them among 2 groups, and fair share means each person gets 2. So again, I may have some plates there that they're going to divide those 2 out. Just so that they understand what that problem means. And we're just looking at one of the x's. And so, or I may have 2 x's there, and they lay on top of each x the counters so that they understand that. So I want them to make sense of the problem, and to make sense of the problem, many times we have to have a situation in which they understand it. I talk about, if I've got this many people coming to a party and I need to have this many rows of seats, then we're going to divide. Those kind of things that get them started to understand. The next one here is reason abstractly and quantitatively. They have to make sense and see a relationship in the problem. And many times our kids really don't understand that that addition sign means that they're going to add something together. They don't understand that the subtraction sign means I'm taking away from. So they get confused on those kind of things. So giving them that opportunity to do those kind of activities helps our students. Again, using that CSA approach, that's what I want. Concrete, semi-concrete, and abstract. I want them to be able to do those things. Construct a viable argument. Sometimes I don't like to give naked number problems, and by naked number problems, I mean that they've just got a problem there, such as 3 plus 2 equals something. So sometimes to give those problems, I have them to create a story behind it. That helps them to understand what's actually being asked of them, to be able to create an argument for it. So they create the word problem. Model with mathematics every day. We need to be modeling with mathematics, whether it's a bead string, it's Unifix cubes, counters, those kind of things. We want to be modeling with mathematics. So that's going to be some of the things that we are going to do as often as possible. They're going to have some way to model. Now, I use a bead string for every grade level all the way through to doing algebra with it. So think about the things that they can use over and over again, something they're comfortable with, but make sure it's age appropriate. Now, I don't want to go into a high school classroom and see them using teddy bear counters. That's just not age appropriate. But 2-sided counters are definitely age appropriate for any grade. The other thing is Unifix cubes. They're age appropriate. I use Unifix cubes for doing probability and statistics because the colors, right? I mean, we can easily do colors and pull out. So those are things that we can do. Ratios and proportions. Unifix cubes are great for those. The other thing is using appropriate tools strategically. This is not you using the tool. This is the students. Again, with modeling mathematics, it has to be the student doing the modeling, using the appropriate tool. So making sure that the student can pick the tool and they can use the tool. And then, of course, attend to precision. One of attending to precision is, do I know that the addition sign means that I'm going to be adding? Do I understand how to communicate what that terminology is? Many times we skip over vocabulary, and vocabulary is key in mathematics. So we want to make sure that our students are getting that vocabulary that they need, and they can demonstrate it in different ways. They can show it on a graph. They can show it as a problem. They can create a word problem to it. So attending to that precision, and then look for and make use of structure. This one's hard because it's patterns, and we know that our kids struggle with patterns. So getting them to understand that 1 + 1 is 2, 1 + 2 is 3, and see what's happening in that pattern. It's the same thing with when we're doing functions. We want the student to see that. And so it works all the way through for our students. The patterns are everywhere. If we're doing multiplication of expressions, there's patterns in there. If we're doing, I'm trying to think of exponents, there's patterns there. So all of that has patterns, and we want to make sure that we're able to show our students the patterns that are there, and then look for and express regularity and repeated reasoning. We want them to notice the calculations that have repeated reasoning. We want them to understand the shortcuts. Many times we teach a shortcut and then the student can't explain it. So having that, again, the CSA approach, concrete, the semi-concrete, and the abstract, we want to make sure they are able to do all three. Now, mathematics is nothing but a progression. It's a progression all the way through from kindergarten up. So we have to find that sweet spot where kids are to make sure that we can build on their knowledge and their understanding, especially when we're working with their goals and objectives. So we want to talk about the 8 effective math teaching practices. This is the part that you are doing. So our overarching one is establishing a math goal to focus on. For us, many times it's the goal in which you create for that student. So where are they? How do I find that goal? Well, I need to look at where are they in the standards, right? And I need to see where they're at and what's the next level that I need to take them to in those standards to create that goal. And many times we think, well, we're not working on grade level. That's true with our FMD students, that we're not working anywhere near grade level. They wouldn't be in special ed if we were. So we need to look at where are they at? What's the next level I can take them to? But how does it also tie into the standards in which I'm working on? Because fractions is all the way through, starting in 3rd grade, all the way into high school. Multiplication starts in 3rd grade and goes all the way through too. But I don't want to see them just working on 3 times 7. How am I going to build that into what they're working on? And so we're going to have some other conversations about how do I make sure that they are working between those. So our first one is establishing that math goal for focusing learning. And then our next thing that we're going to do is determine how to implement a task that promotes reasoning and problem solving, and also is going to build that procedural fluency from a conceptual understanding. Again, I said they're building the procedural from conceptual, which means I've got to bring out what those counters, those unifix cubes, those things, those manipulatives is going to help them. Quizary rods are great. All of those things need to be used to help that student to build onto that. And then facilitate meaningful discourse. Have that student use the vocabulary, not just you use the vocabulary, but the student uses the vocabulary. And in that, we have to make sure we have good purposeful questions. I want to show you some places today where you can find those kind of things for yourself. And then we're going to use and connect math representations. When I talk about 2, I want them to know that this is 2. I want them to know that I have 2 earbuds. I want them to understand 2 in every realm that they can possibly see, the tally marks of 2. So understanding that along with the representations that come along in mathematics. Elicit and use evidence of student thinking. For us, we are always using their thinking. We're always asking them, what do you know? How do you know that? Why did you choose that? Right? Those are questions that we want to ask all the time so that they tell us what they know. Because I can ask the student to give me an answer, and they may give me an answer, but you don't know what they were thinking. So getting back to, how did you get that answer? What did you do first? Little questions like that. What did you see? when a student is first starting out, well, what do you see? Because I can't be wrong with what I see. So we want to start out with things like that. And then, of course, we want to support productive struggle all the time. And our students do struggle, but we want to make sure it's productive struggle and it's not frustration. Again, I've talked about the math teaching practices. That's what the teachers are doing. And then this is what the students doing. And those are their standards for math practices. There's a reason I went over these first, because when we get into our standards, the standards for math practices is at the top of every single one of our standards. This is the way our students need to understand mathematics, not just our high flyers, not just our regular ed students. All students need this. And I can't stress how many times I say, have them model, have them model. There's some of you guys who have been with me before know that when we model it and we give them the opportunity to use counters, we see great things happen and they start to understand the math. So give them that opportunity. Like I said, my favorite's a bead string, but it may not be the student's favorite. So sometimes we have to learn to do it a different way. I had a student who we were doing integers and I thought I was going to pull my hair out. I've told the story before because we'd done it with counters. We'd done it with unifix cubes. We had done everything we possibly could, and I still could not get him to understand when he was adding integers what was actually happening. And I was sitting in my classroom one day at the end of the day, and I looked up and I saw a balance beam. And I said, that might be the last trick I can ever possibly have. How can I change this over so he can see it? And so I ended up gluing a red pipe cleaner to the negative side. And at the end of the day, the next day, he was like, well, Ms. Kidd, it's a negative number because the negative side is down. And I was like, we finally get it. But it took me, like I said, we used counters. We used red and black unifix cubes. I had used everything I could possibly think of. I'd used a number line. We'd walked a number line. We'd done all kinds of things and he was still not getting it. And it took a balance beam in front of him for it to finally click. So yes, you may have to try different things because that may not be the thing that works for your child. So in our academic standards, I pulled up grade 2 here. You'll notice I love to use these with my parents. These are your overviews. Now in your overviews, what you're going to see is you're going to see the areas, the big domains as we call them, that you're going to be teaching in that grade level that year. Underneath, you will see how they're broken up into clusters. So you will see these are the critical areas that you're going to teach within that domain. So operations and algebraic thinking, we're going to have them to represent and solve problems involving addition and subtraction. We're going to add and subtract within 20, and we're going to work with equal groups of objects to gain foundations for a multiplication. Now, with this, one of the things I like to do is I compare where a student is or should be on grade level and where they actually are. So parents can see that there is a progress. This is where we're at. This is a reason why they need the help they need, because this is where they should be, right? And so I can lay those down and we can compare them and we can say, these are the steps we need to take. And the reason we're writing the goal we're writing. This helps parents to understand that gap that their child has in their learning. I use these at open house. That's another good way to get them to understand. I have older students to highlight where they're at and then what's going to be the next thing that we're going to learn. Those kind of things help our students just to set goals for themselves. Now, this is an 8th grade one. If you notice between the two, we went from kindergarten from 2nd grade where we had 4 to 8th grade where we now have 5, but things change. There's no operations. We just had the number system, right? And now we have expressions and equations, because in 8th grade, we start really looking at that algebraic part of this. We have functions, and then we have geometry, and we've added statistics and probability. So these are the things that we'll be working on. Again, how can I use this overview? Think to yourself about how you could use this overview with a student who's maybe in high school, but is working on an 8th grade. And I may even pull out this 8th grade at the time and just have this as this right here, because this is where they're working. And so they can work through it if they need to. So think about some of those things on how I can use this, even with a parent. Now, this is an actual one of our breaking down our standards. And I want to just kind of talk to you real quick. Like I said, every standard here has these math practices at the top. The great thing about the math practices is you can click on these and it will tell you what they are. The other thing about our standards is it tells you which math practice you're going to mostly be using, right? So this says I want to be using math practice 2 and math practice 4 for, this says we're in the Kentucky one, right? So this is Kentucky 4th grade, operations and algebraic thinking, standard 1. This is standard 2. We're under the cluster here. So these will be little formative assessments. When I finish the full cluster, will be your summative assessment. Okay, so I would teach this and I would do my little formative assessments. I would teach this and I would do some more formative assessments. And then this one, again, formative, and then use all 3 of these to do my summative. The great thing over here in our clarifications is now that it gives some examples of some problems that you're going to be using. So it really clarifies what the student needs to be doing over here in the mathematics here. The other thing is it allows me, so I'm in 4th grade. If my student's still struggling, I can go back to 3rd grade and I can look at that standard to say, oh, this is something they may need. So these are linked. It'll take you right back to that 3rd grade one. Or if I'm talking to a parent and I said, you know, we're working on this standard this year, but next year he's going to be expected to do what? So I can click real quick on the next one and it shows what the next standard would be. So, or this is where your kid's working at right now. Our goal for next year needs to be, and this will give us our goal for next year so that we know. So that's one of the things that we need just to consider when you're looking at your standards is these are linked there. And I love the fact that they're linked because before we had those, they were progressions, right? But they were all in one big list and you had to kind of go look them up and those kind of things. Well, now they're right with your standards and you don't have to worry about that. Now you'll see this comparison problem chart here. There's some in the very back of our standards that you will definitely want to look at. They've got some great ones back there in the back of our standards. I think they're 256, I want to say. I may be wrong on that number, but they're at the very back of our standards. They've got different charts that you can use to help you to design word problems. Now, your targets. Your targets are a little different when we're looking at them. So when you're looking at your targets, well, I can't say they're really different because they're the standards. That's the reason why I wanted to take you through the standards first. They are your standards. So when you get your page for your targets, you're going to see there's color coded. And each one of your color codes tells you if it's a fall testing window or a winter testing window or a spring testing window. So you will know according to how they're color coded when that's going to be tested. Again, you have the regular standard here. They have not changed that. There's just this target. Instead of those numbers being all the way up into the thousands, instead, we've limited to comparisons within 100. Your alternate clarification here is students can use a box, a question mark, or a sticker to replace as a replacement for unknown. So we're going to look at, we can use a different thing instead of just having this little question mark here. If they need, they can have a box, right? I like to start these out on a bigger sheet of paper. And I write the problem down, and instead of the question mark being there, I put a sticky pad. So they have a little sticky note here. And it's like what would go there in place of it. And sometimes I put the whole answer out. So a good example, if it's 3 times 5 equals 15, I would have my sticky note over the 15, right? And I would say, now think about that problem and what would be the answer? And that's where this is going to go. If it's the other way around and it was 3 times the sticky note, the 5 would still be under there, equals 15. And then I can move it around for that student. When they get comfortable with that, then we change out to that question mark or just a plain box or something like that. But giving them the chance to just talk through the problems first with an answer available really helps them to understand what they need to be doing. And so you can see there's different ones here that you're going to be working with, but you have to work with all 3. That's the big kicker here. All 3 comparisons have to be used. Many times we'll see somebody who will create a worksheet and they only do a part of it. Brenda knows we've looked through several back when we used to have the folders, and we'd say, well, it doesn't meet the standard because they only had one piece of it. So maybe they only did unknown product. Well, if they only did unknown product and they were just giving the answer, then they didn't meet the full standard. So make sure when you're looking at this, you're looking at that clarification and you're saying, yes, did I do all 3 pieces? If I have not done, and you may not want to do all 3 on one day, that's fine. But that student has to be exposed and taught all 3. So at some point during the progression of them doing this, they need to have all 3. That's the reason I said I like starting out with just that sticky note over if I'm using this one. And that way they understand all 3. But now look down here. I was just talking about multiplication. So I'm guilty of this too right here, because what else does it say here they have to be able to do? Look down here at the bottom. They have to be able to understand this part of it too, right? The division part in this. So group size unknown, that's when we turn over to that division. So making sure that they understand how that works and they've got their fact families together for multiplication and division. This is that chart I told you about that was in the back of your thing. We're going to find some samples of these word problems and they're right here. So these are some good examples of word problems that are in the back on table 2. Now, assignment review protocol. Now, this is what I wanted to kind of talk to you about when you're creating your activities. We tend to see a lot of low-level activities. We need to see those in the very beginning, right? We want to have conceptual complexity activities too, where they're on just this level. Nothing wrong with it. But I should not see that student staying on just that level, because if I do, then that student hasn't had the opportunity to really go through and work that line of reasoning that they should be able to, where they're explaining it, whether they're working with it and they're making a judgment call on it. That should be all the way through. They need to work all the way through that task. So looking at your task and seeing where it is. With some of ours, remember, we start here, but we're going to move to the procedural. That's getting them to just use the numbers, as we said, and the symbols. But then we also want them to go all the way here to where they're making up that word problem for it, right? They're understanding and they're explaining it and they're getting into it and they're diving into it and they're recognizing. They can even say, this is why this is happening. Now, for some of our students, they may not be able to get to this level very quickly. It may take a long time, but you will see those that after you've done, I said, you've pulled out and you've modeled. I promise you, if you pull out, you model, and it's not going to be in one day. There is no child that's going to get it in one day. But those children who we do it 3, 4, 5, 6 times, we can start to change over, and we start pulling in the procedural, and then we pull in the application. And after a while, they get to this point. Now, you're going to have to, again, do some leading, but we have to get away from it and make sure they're the ones using those materials. So having that ability for them to do those kind of things. I'm going to show you in the back. I'm going to actually pull it out of this because I want you to look at the look-fors. When you have questioning for your students, this is in the back on the resources. These are the standards for math practices. These are the possible student questions that are going to go with it, the actions their student's going to take, the actions you should be taking, and questions that you can use. Many times we don't know the questions that we need to ask. So this gives us that opportunities that you can to be able to do that. Somebody put in the chat, any suggestions to get for nonverbal students to explain or develop their own expressions? If they are nonverbal and they have the ability to choose, many times I used, especially if it was a procedural thing, we would use problems that were cut up and then they had to organize, right? They had to organize them into what the next steps is. Rhonda, have you ever used worked examples?
Yes, it's Rhoda, but yes,
Oh,
we have.
okay, so you've used worked examples and you know what worked examples look like. Now,
Yes.
I'm not talking about working an example. I'm talking about a true worked example that's already done, number lined each time and everything.
Yes, I'm talking about our severe students that are maybe nonverbal, autistic, that are
Mhm.
non-participatory.
So one of the things that what I've used before is we've had those worked examples, right? And they would start out by doing a matching. So they would, and it's just, it could be done with on the back of it, it can be magnetic to where they're just moving them around on a magnetic board if they can, or they point to what's the first step, what's the second step, what's the third step. And
You would
so
consider that student explanation then?
yes, if they can do, if you can have the problem out there and it's done in step by step by step, and they can tell you what's the next step to get there, that's student explanation. And many times that's what we need, because if you think about it's truly 4 steps, but a good 4-step problem is of 2x plus 2 equals 6 or 8. I said 8 earlier. There's how many steps to that, right? And so what's the first thing I'm going to do? What's the second thing I'm going to do? And those are pulled out, and if they're just mixed up and you can put them in order, that's a perfectly good way for them to start to explain how I'm doing that problem.
Okay.
So this is the look fors, like I said, and this is the possible questions to promote for you. These are questions that you can go down and look for. These are provided to you on KDE's website. So, and it's got each one of the math practices that are available for you. The next thing I want you to be able to see is this is the Kentucky Alternate Assessment website. You'll see they've got mathematics, English, social studies, science, and then there's additional resources that you can pull from. Now in this one, you go here, this is the alternate assessment math resources. You can go down, you can see the grade level. These are the grade levels that are there. So if I was working with a 4th grader, I'm going to go here. These are the ones that I need again to be able to teach, right? So I want to go to 4th grade. This will bring it up. The cool thing about this is it talks about how you're going to use those math practices to do this standard. Here's your alternate assessment target. You're going to have your clarification over here. On down, what I love about this site is we put in instructional considerations. So these are possible misconceptions, difficulties that the student may have. Here are all the visual tools that you would need when teaching this. I'm going to be honest with you, I stay away from fraction circles. They're great, but they're more confusing than fraction tiles and fraction squares are. I love fraction squares and I love fraction tiles because it's more linear for my students. So when I have to transition that over and when they see questions in the text or on the assessment that is more linear, these two allow for that. And of course, number lines and the fraction tiles and the fraction strips are more linear. So it equivalates to a number line. Other considerations that you're going to have, and then additional resources that you may want to find. So when you go to this site, like I said, I love the fact that you can do this by your grade level, but also you can do it if you need to. I can look at it and I can say, okay, in fractions, here's my third grade ones that I should be teaching. Here's my fourth grade ones, and here's my fifth grade and my seventh grade one. So these are the ones that I'm going to be using for the progression. So you have that progression here. Then, of course, one of the things that I wanted to show you is if you're thinking about breaking down the standard on your own, I want you to think about a couple of things. You're going to break down that standard according to whether it is conceptual, procedural, or application. You are going to look at it and you're going to consider, what are my instructional assessments that I want to do? You're kind of going to do that backward method with this. So when I talk about backward method, I'm going to look at a standard. I'm going to create the assessment first, right? And then how do I want to teach those? And then I'm going to teach it. And then we're going to assess. So we're going to kind of use that backward method. So what key mathematics should students know and be able to do? Well, during that, I'm going to look and see, again, if we go back to that alternate assessment that we were doing earlier, that's exactly what we did here. We went through and we did, what's a possible misconception my student's going to have? Then what are some things I can use to teach this with? And then considerations that I'm going to have to do. So those are really already done for you if you want to break down the standard for you here. But keep in mind, when we're breaking down a standard, sometimes it's more for my use to be able to really understand that standard for me to do this. And I always look at what's the vocabulary that I'm going to need to be teaching for my student. So what's that vocabulary they may need? I love worked examples. And like I said, I love using the CSA approach because most of the time between those two things, I can really get a student moving. Now, I am going to say, like I said before, I've used multiple different tools, and sometimes that tool doesn't always fit that student. So we have to find a different type of tool, and it's going to be some plug and play sometimes, but don't be willing to just say he's not going to get that, because he or she will get that at some point. You just got to find another avenue. Go back to here. Of course, your resource document that you have. This one right here gives you tasks that are aligned, and they show how they're partially aligned or weakly aligned or strongly aligned. And if we go into the kindergarten one and we download it, you'll notice they give a task and they talk about why it is strongly aligned. So if you have questions about, am I aligning my stuff to the document or to the standards like it should be, please go in here. Please look at this and say yes or no. Am I aligning this to the standard the way I need to be? And does it truly fit that? And it gives you examples of each one of those. And so, like I said, we're not leaving something out. Like I've said before, I know we tend to think, oh, well, they can't do that part, but we've got to still teach that part. We can't leave it out. And we got to make sure that our students are given the opportunity to learn those. So these are a way for you to do the alignments. So going back, can't stay here. We've got to move on, and we got to make sure we're here during this. I want to show a couple of activities that you can do for your students. Let me grab them real fast here. I'm going to start with just having a number line or a number board. And I always laminate mine so that you have that opportunity. So I'm taking this number board and I'm going to laminate it, and I'm going to have them to have opportunities to be able to pick and choose. Now, we had talked about if you're having trouble with them understanding and they're picking and choosing, maybe we want to have just a couple of cards and they're using that. And so they're pulling from those kind of things if you're getting them to talk about it. Another thing that you can do is if we are working, this was always one of mine, is if you're working with your kids and you're needing them to count money, okay? And that may be one of your goals, is for them to be able to count change or to count money. One of the things that I do is I have them first start recognizing the coins. And then again, as they start to recognize them, and they can say 25 is, I'm gonna put it on the 25, right? So it's going to be right there on 25. And then, so here's a quarter, goes on 25. I have 2 quarters. Now we're going to count up. They may have to do counting up to 25 again, and then they'll put it on the 50. And then if they have a dime, they're going to do the next one. This is just one thing that they can do to be able to do that. Now, I also have my students using different colored markers if they need to be able to circle parts of the problem within here. And so if it's adding up, they'll say, okay, it's 35 plus 4, and they may X those all the way up to the 4. What was the last one that you did? And so different activities that you can do, just having them to work through this. If it is a student that's just struggling really bad and they're having trouble being able to see it on here, I let them, because of the size of this one that I have, they can lay Unifix cubes directly on top of it. So having that opportunity for them to lay Unifix cubes directly on top of this helps too. If they're having trouble because they're having to go back over here, take this, cut it apart. Now they've got a line, right? They've got one big line that they can use. And so they can lay that Unifix cubes right on top of that one line. And so now it's linear and I don't have to worry about it. This is another thing that you can do for this, to be able to make sure that they can start to see it. Especially my students who have trouble, if they have trouble coming back, kids who have vision issues have trouble coming back, those kind of things. So please make sure, if it's something like that, that you have that opportunity. I took my bead string and used perforated golf balls and made a huge bead string across my room. So I had a student who was visually impaired who could actually move with the bead string. Those kind of things help our students. So don't let it be a resource that's going to cause the issue if they're having trouble with that. Graphic organizers have to be taught to the student. And I can't say that enough, but they have to be taught to the student. The student needs to know how to use them. I use this one because it's easy for my students to see and to do, and to break the problem down. This is for algebra, and it's 2-step equations. So if they're doing, again, 2x plus 6 is equal to, let's do 20. Then how are they going to work with this? Well, they're going to start here. And they're going to say, what did I do to X? What do I do to get to X? So I go up here and I say, oh, I times it by 2. So this becomes 2x. And then I say, well, what else did we do to 2x? Well, I added 6. So now it is 2x plus 6 is equal to 20. So on this one, if I added 6, and I know this is hard for you to see because it doesn't want to write because of the way I'm doing this, I will say if I added 6 over here, I'm going to subtract 6. And so 20 subtract 6, and I may even have cubes out here. I may have something else out here that they're going to use to show me while we're doing this. And they're going to say, well, it's 14. And I'm going to say, oh, well, now I have to do what? And well, I multiplied it by 2 here. I'm going to divide by 2 over here. So we're going to do the opposite of, we talk about that. And I'm going to say, well, if I'm dividing by 2, we are fair sharing between 2 people. And so they'll take the 14 counters, or they'll take 14 beads, and they'll fair share in both directions. And then they have 7 on one side, and 7 is equal to X. Again, we're going to do this multiple times with the student. I'm going to show them how to use this. This is something they could easily draw out very quickly. I'm going to then later change that over to where they're not just drawing this out. Maybe they're starting out with this 2x plus 6 equals 20, and they're talking it through. And so they just draw lines and arrows till they get through to it. They start creating their own graphic organizer, right? So that's one of the things I want them to be able to do. But I have to teach them how to use the graphic organizer. I can't give them a graphic organizer that's already filled up. They have to be able to use it on their own. It's one of the things that we want. The other thing is make math fun. Math can be so much fun because we have all kinds of tools to use. The other thing is we have games that we can play that's going to get them to where they need to be. They're going to be building and taking apart, deconstructing things all the time. So make it fun, especially with angles and those kind of things. We can create all kinds of stuff using angles and build and process, but also connect it to careers and things like that, that they know that's out there who uses the mathematics in this way, because we have so many things that are out there that they can do. The other thing is your favorite thing should be maybe a deck of cards. So, and the reason I'm saying a deck of cards is this is a 1. It automatically has your 1 here. This is 2. It has your 2, right? They can point to these and see them. So if I'm doing 3 plus 2, I automatically have 1, 2, 3, 4, 5 right there available to them. Now, when I get a little bit older and I'm doing integers, I have 6 plus -3. At this point, one of the things that I can do is I can go, oh, look, the -3 takes over this. What do I have left? I have +3. So 6 plus -3 gives me +3, or 3 plus -3 plus 6 gives me +3. They are able to see that and use it. I use this with you can use it with a group of kids, or if an aide's doing an activity with it, they can play amongst themselves to do activities. Keep it within 20. That's another game that they can do. So we keep it within 20. The red, believe it or not, is subtract. And all the black cards are positives. So what does that count out to be? What's something else that you know, if you're in the red, it's negative? Your bank account, right? If I'm doing this and it's my bank account, then it's going to be red. So one of the things that I want to think about for this is I'm doing keep it within 20, and let's say I start with 2. So I tell my students to bring out the 2, and that's what they have. And then they draw 2 more cards and they get to choose. Now this is where they choose these 2 cards. Now this is the card they started with. And I say, if we're going to keep it within 20, it means it has to stay between 0 and 20. I get to choose one of those 2 cards. What are you going to do? Well, of course, I want to choose the +3, but our students may at first say, I'm going to choose, and this is where we were talking about, can my student choose and say, this is going to be right or wrong? And us know if they understand if they're keeping it within 20? Absolutely, because if they choose a -5, you can show them how that could be a negative number and it's not anywhere within the 0 to 20 by doing hops on a number line and taking it back into the negative numbers. Now, if they choose this, they've got 5. Well, now you still have this -5 here, or subtract 5, and let's say they get a +4. So at this point, what do I want them to do? I want to choose which one they're going to do. Now, at this point, they can say, I'm going to subtract 5 and I'm going to be at 0. So we're starting over. Now I'm at 0 and I can add 4 or add 5. They can choose either one of those, right? And so they would do that. And then they would draw again. Let's say they chose to add 5. So now I'm at 5 and now I'm choosing one of these. Now I can add another 5 or I can choose to subtract 6. If that student chooses to subtract 6, I'm going to show them somehow on a number line that they're going to be at a -1. That's not between 0 and 20. So can I actually subtract 6 and stay there, or do I need to add 5 more? Now, if I add 5 to 5, it becomes 10. And they when they start to understand that, you start to see that they are where they need to be. Sometimes I don't have my students to actually do the problems there. They're just moving their counter on a number line. And they're staying where they need to be within that number line. So they're not actually writing these down. They're just moving the counter to where they need to be. So another way that you can have it, especially for those students who have trouble writing, they may not want to write that, but will they move a counter or will they move an object on a number line? Sure. And that's another way that I can make sure they're doing the math. So make it fun. Make it something that they want to do and they want to be a part of. If you have any questions, please feel free to contact me. Or if you're concerned about a thing, if it's matching your standards, or if you're you don't know if your alternate assessment, if you've done enough for that student to be able to understand a standard, just contact me and say, hey, what's something else I can do? I want to share my screen again so that you have my email. Say goodbye.